You have already learned that in statistics, sampling will play a huge part of the process. More specifically, we're always going to be looking for a representative sample, or in other words, we want our sample to match the demographic of the population it's taken from. And what is the best way to attain a representative sample? It is to use some type of randomization in your sampling process. For the purposes of this class, we will be using something called a simple random sample. Abbreviated by its acronym SRS. By definition, a simple random sample ensures that every member of the population has an equal chance of being selected. While you might not necessarily know the term simple random sample, most students have had experience with the idea of a random selection. You might have heard of the concept of picking out of a hat. Let's bring a hat into the situation over here. So what often happens? You're looking to see who goes first or who goes on what team, and you want it to be fair. So what do? You take the names of everybody on a piece of paper, crumble them up, put them in the hat. Don't look, reach in, pick out. Voila, there's your randomization. All right, let's simulate that with just a simple scenario. Let's say I take some letters of the alphabet. Let's say up to H, okay? It looks like there are 8 of those. If I put those on a piece of paper, put them in the hat, crumble them up, if I reached in, what would be the probability that I have selected any one of those letters? Clearly, there's 8 options, and only one is coming out, so that would represent about exactly a 1/8 probability. We had an easy time of things in this problem because our population was made up of just 8 letters. But things can get a little bit more involved when we're getting a larger number in our population. If we had 75 or 500 or even 1,000, like, do you really want to throw letters, 1,000 letters on pieces of paper and put them in a hat? I would say that would not be very fun. So we probably wouldn't want to do that. So what is the alternative? We have something called a random digit table, which is exactly what you would expect it to be. It is a table full of random digits. The digits are in the body right here, the actual digits. And around the outside, you're going to see row numbers and column numbers. The row numbers are self-explanatory, 1, 2, 3, and so forth. The column numbers are a little bit, it can be a little bit tough only because they number them 1 through 5 here, so you sort of just have to visually be like, all right, like this is 1 through 5, this is 6, 7, 8, 9, 10, 11, and so forth. They just can't fit the numbers in there, which is why they group them up the top here. So don't overthink it. Each one is basically its own column number. Okay, so when you're actually asked to use the random digit table, what you will be presented with is a row and a column number to start your selection process. So, for example, I could be given row 10, column number 21, which is going to be this one right here, which means we would be starting basically right here. Note that you always have to be given a place to start, especially on exams or on homeworks, because there has to be an answer key of some kind that can be consistent. If I just said pick random numbers, you could start anywhere in the table and everybody's going to get a different answer. That doesn't make a lot of sense for grading purposes. So you're always going to be given a row and a column number. Okay, so let's see how we can use this table in order to make a random selection. So let's write this out here. What is the SRS process. Say that several times fast. Well, SRS process, there's two main things here. First, you want to number your population. Okay, in this case, it looks like we have 8 digits here. So we could number them 1, 2, 3, 4, 5, 6, 7, 8. And the second part of the process is to use the table to select your sample. So how would we do that? Well, you'll see that the number of possible values that we have in our population is 1 through 8. There are 2 other single digits that are possible, 0 and 9. We are not using those. So our goal is to go into our table, which is here, start at, let's just use what I used before, 10 and 21, and pick single digits that are between 1 and 8. It turns out our first value is 8. So therefore, we would go back to our problem and we would say that letter H would end up being the first member of our sample. Now, if you're just looking for one selection, then you're done. It's H. But let's just say, for argument's sake, that we wanted to select a sample of 2. Well, we would go back into our random digit table, and by the textbook's way of doing things, you would go vertically down with your digits. So you would go down to the next digit below it, which is the number 4. Therefore, you would go back in here and you would say, that means letter D would be the next member of our sample. So therefore, the letters H and D will be our sample in this problem. Okay, so why do we need to use double digits for these single digit values? Well, let's take a look. We already said that there are 10 single digit numbers. So therefore, if you actually want to find the probability of going in your random digit table, let's say this random digit table, and selecting a single digit number, then it would be a selection of 1 out of a possible 10 of them. Here's the problem. If you go to double digit numbers, which are going to start at 00, 01, 02, ... all the way to 98 and 99, there are a total of 100 of them, which means that reaching in and picking from the random digit table any one number out of these double digit numbers is going to be 1 out of 100. Okay, so what is the definition of a simple random sample? As mentioned, every member of the population has an equal chance of being selected. So, if some of these numbers here, these letters, are numbered by single digits, and some are numbered by double digits, then the single digits will only have a 1/10 chance of being selected, where the doubles are 1/100th. That violates this definition, because every member wouldn't have an equal probability of being selected, which means we have to ensure that's always the case. Hence why we have to make sure that when we number our population, it's always by a consistent number of digits. Okay, so how will we pull off random selection in a scenario where there are 12 items and we're using double digits? So let's see what that looks like on our table. So let's change our column. We'll stay in the same row, just make things a little bit easier. Let's say we went over to column 12, which is right here. Okay. So if we make our way down, you're going to see that the number we're going to come to is 0. But because we're picking 2-digit numbers, then we also include the next column. And the first number that we come up with is the number 02. So we would go over here, we would say 02, which is letter B, would be in our sample. We would then go, okay, let's say we're picking 2 again. So we would go down. So we would go down to the next 2-digit number, which is 01. And we would say, okay, that means that letter A is also going in our sample. So just to be consistent, if our sample is 2, this time we're going to get AB. Last time we got HD. Let's do a little housekeeping here. It turns out that we have variables that represent our population size and sample size. Our sample size is always going to be little n, and that's pretty universal around a lot of topics. But we need a different variable for population size, which is obviously going to be a different value. So to make things simple, statisticians just made it capital N. So in our 2 scenarios that we have over here, we started out with a population size of 8, and we chose a sample size of 2. On this one, our population size was 12, and we decided to again pick a sample size of 2. Okay, now that you've learned all about the process of finding an SRS and some smaller examples, we want to do a larger example and really tackle the entire topic. So here we go. It says find an SRS of n equals 5 from the population of capital N equals 50 states. So remember, SRS means simple random sample. We are supposed to pick 5 states according to this, because little n means sample size. And our population is our capital N equals 50 states, our population size. Okay, so remember the process of selecting an SRS. The first thing we always must do is we must number our population. In this scenario, it looks like we have states that are in alphabetical order. We also have them numbered already, but there's a major issue. If you were following along with the lesson, you can see that we have 9 of these numbers that are single digits, and the remaining 41 are double digits. That is not allowed because of the same explanation that was going on over here. These will have, obviously, different probabilities of being selected. So what do we have to do before we get started? We have to make sure that we put a 0 in front of all of these guys so that every single number for the population that's being identified for each member must be a double digit. So note on an exam, you will likely be asked to just write something out like this over here, number 01 to 50, just to let me know that you understand what you're doing. Okay, so the second step of the process is we need to select our sample. So what are we doing? We're going to the random digit table. Let's assume for argument's sake that we have been asked to use row 18 and column number 9. So 9 is going to be right here. And we're using double digits. So we're going to be using, basically we're going to be starting right here at 09. So how does this all work? Well, remember that the only states with numbers, Alabama to Wyoming, the numbers that are present are 01 to 50, which means if we see a double-digit number that is not in that span of numbers, the span, then we ignore it because it is of no relevance to us whatsoever. But if it is a number that is labeled in these states, then that is going to be a member of our sample. Going back, our first hit value is 09. If we go back into our random sample, you will see that 09 represents the state of Florida, which means right away that our first member of our sample is going to be Florida. Okay, so remember the process. We need to go vertically down. So the next number down is the number 17. Is the number 17 in our population of states? It absolutely is. It can be found at Kentucky. So we're going to write Kentucky as our next member of our sample. One more time, going down 1, we get to 42. 42 is, of course, again, in our sample over here. We can find that state. It is, looks like Tennessee. So far, we're doing pretty well here. We have 3 of our 5 states that we need to find. We only need to find 2 more. Okay, so moving on, you might have noticed that I have purposely selected a scenario, specifically a row number that was low in the chart. Why? Because I needed to show you where we go next, because there's no number below 42 and we still have to pick two states. So here's the key. We used row 9 here in order to start, but we needed 10 in order to do double digits, which means what do? We move to the next row. This has nothing to do with the fact that we go to the next grouping of numbers. Remember, there are no groupings of numbers technically. There's no spaces. That's just used for your eyes. So you're just going to the next column number, which is 11. But in order to use double digits, we need 12 as well. So therefore, our next number is going to be 74. But here's the problem. Remember, these are our states. There are no states labeled by 74, which means 74 is not of use to us. So therefore, we basically just toss it out. So if you want, you can X it out. Go to the next number, which is 96. It looks like we're hitting the same problem. 96 is not one of our states, so we toss it. We go to 81. Again, we toss it. Now, you might be thinking, why are we tossing so many numbers? Well, in the world of probability, the numbers 01 to 50 here only make up 50% of the double-digit numbers, which means we're already expecting to get a hit 50% of the time and a miss 50% of the time in the long run. So we are expecting the same amount of hits and misses. We just have to keep on going until we get the hits that we need. Okay, so our next number in the chart coming down, our table, is 31. We go back. You will see that, hey, we have a hit. It looks like 31 is the state of New Mexico. So we can keep on going here. 31. Okay, we're almost there. We need one more state to be in our sample. So we're going to go down here and we're going to go down one. It looks like 88 is not in our set. And then we get to the number 42. Looks great. It's in our values. We go over here and all of a sudden we go, uh-oh. So it turns out that 42 has us picking Tennessee again. That just doesn't make any sense. We're looking for 5 different states. We don't want to repeat a state. So when you're picking a sample, no matter what the topic in this scenario, if you get a repeated number for an SRS, you basically treat it as a number not in your values here of your population. So therefore, even though it's good, we need to skip it and move to the next one because it's a repeated value. So skip values that are not in your span, numbered the population, and skip repeated values. We go one more, and it looks like we finally have lucked out and found our last value, our last state, which is going to be North Carolina. So in summary, this is a good scenario of using vertical columns in order to choose a sample from a population. This is something that you will be doing on your exam and on your homeworks. So just make sure you are clear with this and understand it very well. Now note beyond that, is this something that you would do in a real world setting? No. Normally random selection is done using a computer simulation or a program, some type of algorithm of random digits. Unfortunately, it's very difficult to do that in an exam situation in a course like this. So that's why we use the random digit table.